Hi, I'm Bill Vass. I'm the Chief Technology Officer here at Booz Allen. I think the modern technology flywheel is very transformational, and it's important to understand this has been developing over about the last 10 years. And it starts with connecting and collecting all data. I mean, data is the new gold because you need data for very dense parameters in machine learning. The next thing is leveraging machine learning to generate synthetic data from your real data. And that allows you to do edge cases. And I think that's important. You'll never be able to get enough edge cases in the real world to test all possibilities. So you combine those two things together, and then you apply that to your digital twin in the cloud. And the digital twin is a software-defined environment that represents the physical world or an ERP system or whatever you're doing your development on. And then a combination of that software-defined environment and the machine learning training that can happen in the cloud using that data allows you to do tremendous acceleration of the machine learning model growth and its understanding and test all the edge cases in the software. That allows you to then have a much more robust software and machine learning system that you push back out into operation, which generates more data, which lets you do better synthetic data, a better software-defined environment, a better machine learning model, and the whole thing just accelerates. So software-defined environments are really key. As the saying goes, software is eating hardware. The software-defined environments allows you to have a lot of flexibility, allows you to make changes very quickly. A software-defined car, for example, would differentiate from a hardware-defined car. Simple thing like if you put a window switch down on a hardware-defined car, it's connecting a circuit and running a motor. On a software-defined car, it's sending the signal to a central computer and it runs the window. In the software-defined car, it can do things like have the cameras notice that it's raining and roll the windows up for you automatically. In a hardware-defined car, it can't. So that's one big differentiation, is this ability to be software-defined. The second thing is in the software-defined car, you can update it every day. You can add features. You can be continuously improving it. And a third important piece, in the software-defined car, you can create a virtual car in the cloud and do millions of miles of driving in an hour, which you physically can't do with a hardware-defined car. You can't test it that much, right? It's not physically possible. Those things together really accelerate what you see happening in the automotive industry. And so if you extrapolate that to a drone or to a Navy ship, making a Navy ship software-defined allows you to create a digital twin in the cloud, allows you to pull real and synthetic data in and test it, do 30 years of testing, driving the ship in the cloud, for example, updating the software, improving your machine learning models, and then pushing it back out to the ship quickly. And that's going to be critical as we move forward in the future, the ability to have cycles of update that are monthly or weekly, or even in a battle minute by minute for machine learning model updates from the 2 to 7 year cycles we have today. So everything needs to be moving to be software defined.